We've already talked about this when we talked about the heating curve. The position or composition energy is called what? Potential. Thank you. It's going to be the potential energy, the positional energy, where the molecules are arranged. And the energy that is due to motion is called kinetic energy. Very good. Quick little review of kinetic and potential energy, because you'll see one of these on the test. Go back. The heating curve. And if you remember the heating curve, the solid's in a nice crystalline structure. The solid is warming. The liquid is warming. Spread out a little bit. The particles are more spread out. Have a little bit more free range of motion. Gases are completely moving. This is the slopes are the state of matter as they're warming, increasing their kinetic energy. This is the main focus of the specific heat. The warming phases. The warming time. Remember, in order to cook your spaghetti, you can't just put the pot of water on the stove, turn it on, and it's going to be instantly boiling. You have to let it heat up. It has to get those molecules moving faster. And then it gets to a point where it finally gets up to the boiling point and it starts bubbling. But this part where you're heating your pot of water, that would be the liquid warming phase. Okay? Very important, because we're going to be talking about specific heat and being able to warm things. The SI unit for heat is called joules. Has quite an interesting spelling. It's after a guy who came up with this. Sorry, what? Well, it's for the spelling of the person's last name. So, another one, and we would abbreviate this just with a J. Kelvin's actually a measure of temperature. The other unit of heat that we frequently use is called a what? CAL is short for calorie. Good. Now, one thing you need to note about calories and joules, 1 calorie equals 4.184 joules. And specifically, this is important because this ends up, both of these values also equal the specific heat of water. Everybody remember talking about that water has a really high heat capacity, can absorb a lot of energy, release a lot of energy before it's going to change its temperature. That's significant for us because, you know, the oceans help moderate the temperatures because they don't change their temperature all that quickly. If you think about it, when we get out of school, you know, in June, you go racing off to the beach, try to go in the water because the water is really cold at that point. It takes like 2 months of summer before it starts to get really warm. So the beach is much more pleasant in, you know, late July or August because the water of the ocean has gotten a lot warmer. But it does take a considerable amount of time and a lot of absorbing of heat for it to finally warm up. The fall time is also true. You can still go to the beach in September and October because the water's still warm. Why is it so warm? Because it hasn't had time to cool down and release all that heat from it, where it's finally cold and you don't want to get in it. Okay? How many joules are in 230 calories? Well, this is going to take a simple T-chart, dimensional analysis. What do I do with my calories? Diagonal them down. What am I going to put up top? Joules, right? Now, if we remember from the last slide, 1 calorie equals 4.184 joules. Oh, by the way, you do have to memorize this conversion because on the SOL they do not give you a table, a formula, or anything. Okay? So you need to know this one, the water one. Other ones they'll provide you, but water is significant, so you do have to memorize the water value. since the conversion factor is based off of the water. So here you would multiply, get your answer, follow the same significant digit rules that you had in the past. Start with 3, you're going to end with 3, and in this case, we end up getting 983.24 would be the calculator answer. 1, 2, 3. Do we round up to 3 or leave it a 3? Leave it a 3, so therefore your final answer is 983 joules. Now, I believe on your paper there's a typo here, so for number 2, they wanted you to do kilojoules there. So I want to look at doing, number 1 is very similar to what we just did, except for it's in reverse. You diagonal down the joules and you go put the calories on the top. But 2 and 4 are both, because we have kilojoules, okay, calories and kilojoules here. Those are going to take 2 steps. So if you want to review your 2 steps, so let's go ahead and work number 2. If we have 85.0 kilojoules, I'm going to diagonal down my kilojoules, and I can go to what directly from kilojoule? Joule, because it's a base unit. Good. So we can do our King Henry died by drinking chocolate milk. If I see kilojoules, I can go to something else in that Joule family with the prefixes here. So, kilo base unit is where joules is going to be. Who's larger? Kilojoules gets the 1. It's larger. How many hops down? 1, 2, 3. That's 10 times 10 times 10. So how many joules in a kilojoule? 1,000. That's our first step. But we don't want joules. We need to keep going. We got to get rid of joules and go to calories. So we're going to put that up here. And what's our conversion factor for that? 1 calorie equals 4.184 joules. Now multiply everything on the top, divide by the bottom. Okay? So if I were using your calculators that you have to use on the test, because those are the ones we give you for the SOL, this is how it would look. Okay? So, starting over there, I would type in my 85. I would then multiply the kilojoules to joules. So 1,000, multiply by 1,000, and then divide by the 4.184. Hit enter. So I do it in 3 separate punches. 85 times 1,000 equals divided by 4.184. Is that right? Did I do that right? So make sure you're using your calculator right now. This particular number, we need to round to the correct number of sig figs. So, how many do we have over here in our measurement?
3.
3. So we're only going to be able to keep 3. So, how do I make that have 3? I keep the 2, the 0. What do I do to 3? Round up or leave alone? Leave alone. What do I do with the rest of these place values in 0, filler zeros? Good. So this would be your final significant digit answer. So go ahead and try to set up number 4 this time on your own real quick. It is going to take you 2 steps. It's calories to what? It is calories to kilojoules, but what's the first step going to be? Calories to joules, and then joules to kilojoules. So just try that real quick. Set it up. Did you get what I got? Good. Now we're going to move on. If you want to try the other conversion factors, you can. I'm going to post a key tomorrow after class, and you can go back and look through those separate ones if you need more practice. The heat is, the given symbol is Q. We're going to use Q when we're referring to heat. So filling in our variables now, because we're going to be using a formula. Q is always going to be representing heat. That means Q is going to be in joules or calories. It's going to be some kind of heat unit attached to it. Heat unit attached to it. Got to be in joules or calories. We are going to be looking at the amount of heat required to raise the temperature of 1 gram of substance by 1 degree Celsius. 1 gram, 1 degree Celsius. It is known as the specific heat, and it's given the symbol C, or sometimes you'll see it with CP. Sometimes people just put the C and they leave out the CP. Specific heat is different for different substances. This is also an intensive property. It does not matter the amount. It's always going to have the same specific heat value. It's an intensive property. So write that down. Now, it has a couple possible units too. If you're using joules, it's going to be joules divided by the grams times the degree Celsius. It's a derived unit with 3 units in it. You've got a heat unit, you've got a mass unit, and you've got a temperature unit involved. Or, if you're using calories, it'll be CAL divided by grams times degrees Celsius. Because we're raising a gram 1 degree, so that's the bottom part, and then we're talking about the heat, so it's got to have either joule or calorie on the top. So when we're talking about the unit for specific heat, we need joules per gram degree Celsius or calories per 1 gram times 1 degree Celsius. That's what that means on the bottom. Okay? So there we have our unit, because we're about to get to our lovely formula, the equation that you need to know and memorize. Although you probably won't need to memorize it once I give you the nice little hint. And I just already described why water has a high specific heat. It releases and absorbs lots of energy before it changes its temperature. So we call it Q equals MCAT. I like to not write it with CP, but some people do. Q equals MCAT. That's how I write it. Still means the same thing, but mass, specific heat, change in temperature. So let's define these variables. We already said Q is the heat, and it's going to be measured in joules or calories. The specific heat, CP, is going to be in joules per grams degree Celsius or calories per grams degree Celsius. And M stands for mass. But the mass has to be in grams, by the way. If it's in kilograms, you have to change it to grams before you can use the equation. Now, is anybody familiar with the delta sign in front of a symbol like that for mass? It means the change of. Thank you. Change of. So this is going to mean the change of the temperature, change in temperature. Delta in front of anything in math and science equations always means change of. So what does that mean? That means you're going to take the T final temperature minus the T initial temperature. So we really say TF minus TI. That equals delta T. So if we cool something down, our final temperature is going to be lower than our initial temperature. So that means we can get what here? a negative number sometimes. If we are getting a negative number, all that means, that sign is just telling us the heat is being released rather than being absorbed. A negative value just tells me heat's being released, whereas a positive will tell you that heat's being absorbed. So heat being released is also exothermic from the notes that you looked at and we talked about there. Things that are going to absorb energy are endothermic. Okay? So we're going to plug and chug, basically, is what I say. We take the numbers, we take the mass number, we take the specific heat number, we take the two temperature numbers, we insert them, and then we calculate it out. Okay? So I'd like you to look at this problem here and plug and chug. Now you're welcome to list them out on the side over here if you want to, if that helps you establish the variables. This is what I do though. I put my equation up and then I start finding my stuff. Ethanol has a specific heat of this. Well, guess what? That's this one. So I'm going to put it here in the middle. That's C. Sample has a mass of 34.4. I'm going to stick that here, because that's my mass. Now, my change in temperature is 25 to 78.9. 25 to 78.9. So out of those two, which is my initial temperature? I'm starting with this. That's my TI. The one I'm ending on is my T final. So you can do one of two things. You can go over here and do the subtraction first, whichever way you'd like to, and subtract that out and put the number here. Or you can actually plug the whole thing in and do the subtraction first. But you must subtract this. This is like in parentheses. You must do this operation first before you multiply. So you can do it separately before inserting, or you can do it, but just remember to subtract first. So this ends up being 53.9 degrees Celsius. This is all going to give us the value for Q, our heat. So really it's one big multiplication problem now. And if you look carefully, we have grams and grams that are going to cancel. And we have degrees Celsius and degrees Celsius that are going to cancel. So what are we left with? The only unit left happens to be the joule. And guess what? That goes with heat, so that works out nicely for us all. So let's multiply everything across and get our answer. Q equals, this is the calculator answer, right? Now, we go searching up here for sig figs. The ones that you want to look for your sig figs. Specific heat is like a constant value for each particular substance, so don't look at the specific heat. What you want to look at is the measured values. The temperatures and the mass are both measured values. So out of those, looking at all of them, they all have what? 3 digits, so we're going to keep 3. 1, 2, 3. Do I round up that 2 or leave it at 2? Leave it at 2. What do I do to that 1's place value? Filler 0, and I put my joule next to it, making sure I leave my units in there so I don't get docked for units, because you can't leave the numbers naked. Because on the free response, if you don't have your unit there, you'll get docked. Partial credit. Yes. So, looking at your Q equals MCAP. That formula, the percent error formula, the density formula, all formulas that we show you and tell you about, because there is no formula sheet on the SOL, you will need to memorize them. Okay? But Q equals MCAP, say that to yourself a few times, it's not that hard to remember. Now, let's look at another one. You guys go ahead and set this up. See if you can plug and chug. Okay, let's plug and chug away. Q equals M hat. The mass, right here, I'm just going to place it under where the mass goes. The specific heat, right here, tells me I'm going to put that right here for the C. And the temperature change. Oh, look, it's cooling down. So really it could be 12.9 minus 41.2. So that's going to give me a negative number. And that happens to be negative 28.3 degrees Celsius. So now that's all going to give me Q. Which ends up being a negative value. Now, all of this negative sign is telling me is that heat is being released. Cooling down, heat's being released. This is exothermic. Exothermic. If it was a positive Q, it would be endothermic and heat would be being absorbed. So that's all that's telling me, is that heat's being released. Now for significant digits, we have 3, 3, and 3, so I'm going to keep 3. Do I round up to 4 or leave it a 4? Round it up. Put in your filler zeros. Grams cancels with grams. Degrees Celsius cancels with degrees Celsius, and we're left with our joule. Final answer. Now I'd like to do one other variation because this is an equation just like in algebra. We don't always have to solve for Q. What if they give us the heat? And they give us the specific heat. They give us the temperature change. We could solve for the mass. If they gave us the mass, the change in temperature and the heat, we could solve for the specific heat. So any of the variables could be the missing piece, and you just have to rearrange the variables to solve for it. So I'm going to skip a few examples here, and let's move to one like that. Like this one. Oh, and this one, specific heat example 1. The 0.55 kilograms here, oh, it gave me kilograms. That's kind of a bummer, because now I have to convert it to grams. How do I convert it to grams? Kilograms, how many grams in a kilogram? 1,000. So I basically have to multiply by 1,000 to get 155 grams to start with. Because I can't use kilograms in the equation. So here, it's telling me the temperature change. I can do that real quick. 25 minus the 9, right? That's easy. So that's going to give me 16.0 degrees Celsius is my delta T. But it also gives me, besides the mass up here, that equals the mass, gives me 5,696 joules. Which variable does this one go with? Something in a heat measurement. Which variable out of the equation does that belong to? Well, there's only 2 other ones here. We used M, we used delta T. What are the other 2 variables? What are the other 2 variables? We used M, we used delta T. C or Q? Which one has only the joule as its particular unit? Q. So this value is really our Q value. So you would plug and chug that way. You put the 5,696 joules here. You have your mass, which is 155 grams. We have our delta T, but we're missing specific heat, so this is our variable. Delta T happens to be 16 degrees Celsius. How do you get Cp by itself if you were doing just an algebra problem? How do you undo the multiplication over here? You've got to divide both sides, right, by the grams and the Celsius. What you do to one side, you must do to the other side. Remember, that's how we work it in math. This will cancel, and guess what? Cp is by itself now. Look, now all we have to do is plug this into our calculator and get our answer. Just trying to show those who need the steps for the algebra. If you already understand the algebra, you can plug and chug away. Yes. Because I need to get C by itself. I need to move the other stuff to the other side. So C is my variable that I'm missing, the specific heat. So this ends up being 2.296, 466, 366, 366, and 366. So I'm going to go 3. Oh, but that makes this interesting. The 6 rounds up to 9. The 9 rounds up to 2. We get 2.30 joules per gram degree Celsius. Look, joule over gram over degree Celsius. That's why that's a derived unit. That's why it's has so many in it. So this is our final answer for our CP. So you can solve for any of the variables. Now,